dignitaries on the dais and off the dais. Just before coming, I was just thinking what I need to say, what I should say on this occasion. I jotted down a few points. See, everybody is talking about innovation nowadays. I mean, the cheap product concept is no longer viable. If you have to be ahead of others. An industry survives only if it can innovate. If it cannot innovate, it just perishes. Just a cheaper product concept is not working. Now this, so innovation is something which you cannot define. See, it is ill-defined in some sense. You have examples of innovators, but the circumstances under which innovation happens, the mindset which enables innovation, all these things are ill-defined concepts. But there are certain aspects which probably the policy makers and we educators can look into. One of the issues I thought I should raise today in this August gathering is that is our course curricula designed to suppress innovation or it is designed to promote innovation? And can we ask this question? Is our course curricula is so watertight that a student with a special skill has no room to survive? See, Steve Jobs is a fine example. He could not survive, and this is not only for our country, it is a global problem. How to blend the innovative capability with the regular course curriculum. That is the real challenge, and it's a big challenge how to do it. On one hand, you require some credit course requirements to award a degree. On the other hand, you want to help skills to develop. And a person, see, so this brings me to the issue of what is called a generalist versus innovators. So our course curricula at this point of time, I have been watching for the last, since 77 I am a faculty member, and since 79 I am with an engineering institution. So I come with a material science background. I am not a typical engineer, but I am watching because I have been part of an engineering institution, and it's a premier engineering institution. So what I feel is that our watertight compartment approach for awarding degrees and imparting engineering education will not work. And we need to distinguish between what is engineering and what is engineering science. See, engineering is essentially an engineer, I mean, the way some of us look at it is that you have a body of knowledge and you put it in a product. And that is kind of engineering. But when you talk about engineering science, you are creating knowledge first. And that knowledge is then converted to a product. Professor Mantha gave the example of IBM. 60% of its profit goes into creating knowledge. If you look at the Bell Laboratories, Bell Lab profile over the years, see, they had kept people who had nothing to do with the industry. Absolutely nothing. I know of, for example, Phil Anderson, a Nobel laureate in condensed matter theorist, Phil Anderson. I mean, but why do they keep them? Why did they keep them so long and still support? Why? Because maybe in his lifetime, one idea, one innovative, I mean, they don't know when will he be useful, but they need wise people, people who can think ahead of others. Now, so, see, if you want to promote, let me go back to the theme I started because time is short. If you want to promote innovation, we have to give opportunity to our younger mind to show their aptitude. And where does their aptitude lie? See, you have set up, let's say, 20 courses, and the student is exceptionally good in one, and in remaining 19, he is sort of average. Maybe he fails in one or two. Einstein failed in many courses. So he fails in one or two. Now what do you do then? That exceptional quality, should it get averaged out with the rest of it and he is out of your institution, is thrown out? how you make a flexible structure, thereby this special skill also has a place. And such examples are many. If you look at the history of various industries, how they have evolved, many of the successful entrepreneurs have been dropouts. Where did we err? Where did we go wrong in terms of, this is global. The questions which I am raising is not, they are not just specific to India. It's engineering education. So we need a paradigm shift in any education, engineering education more so. Because engineering education is going to drive the economy. And our economy is going to be driven the way we are going to train our engineers. So this engineering education, and here I believe personally, many of you may not agree with me, engineers may not agree with me, but I believe that you have to bring in a lot of science component in engineering. Just empirical engineering education will not help you to develop innovators. So you have to train a student with certain aptitude and certain skills and certain techniques and so on, which are required to innovate. You see, innovation is not, it's a very fuzzy thing, People who make discoveries, if you ask them how did you get this idea, they never say, I went along this straight line. Just it was a very fuzzy and very non-linear kind of thought process, and suddenly they end up with a great idea, which is called discovery. So I believe that if we bring in more of science content in engineering, I am not talking about physics, chemistry, and mathematics as science component. I am talking about the science of engineering, the engineering science component. That engineering science component is a must if we have to move forward from here. In Western world, this has happened. In fact, most of the faculties there, engineering faculty, they are named as engineering science faculty. In India, we continue to still quarrel whether it is engineering or science. So we have our own problems. We want to survive as one community or the other. We can't have a community which combines the two. So that is, so I feel that I don't have any, I'm just putting questions. So we need a paradigm shift in our course curricula, the way we teach, and so that the students with a special skill, they also get an opportunity. They are not thrown out of the system because they could not clear some papers, but they were exceptionally good in certain areas. So how to retain them, how to make use of their talent, that is our challenge before our regulators. I request Professor Mantha also is here fortunately, that how do you bring in this kind of paradigm shift in which by which you can provide opportunity to such talented mass. That is. Now one more point I wanted to say before I stop. See, we need to keep pace with the research and development which is taking place elsewhere. Now, if our industries, and Professor Mantha hinted on those lines, if our industries have to survive, then they must spend in a very big way. I am talking about the major industries, in a very big way in R&D. They cannot survive on importing the latest technology and then continuing with it for some years. They have to build on that and be ahead of others once they have imported the latest technology. Now this requires a patient approach. Our industry is very impatient. It gives you 5 lakhs and tomorrow it expects a product from you. This does not happen anywhere. You see, they should learn from the pharma industries how much they spend on bringing out one medicine, kind of with billions of dollars. And it's a gamble. It may or may not hit the market. So the industries have to innovate, have to invest very substantially to promote basic engineering science research and they should create some innovation hubs and so on, educational institutions, whereby these are young innovators, if they have some bright, brilliant idea, they have an opportunity and they can demonstrate that. With these few remarks, I stop here. Thank you very much. I may have to leave in between, please forgive me for that. I mean, I would have liked to continue with this function. I was in a meeting and I have been asked to come back because certain very important decisions are to be taken. So I will stay on for a few minutes and then I will go. Please forgive me for that. Thank you.
Any questions,